Hello, welcome back. Let's practice our sum and difference of cubes. Okay, so this is just a worksheet with lots of sum and difference of cubes. Now I think first I'm going to copy in the pattern, kind of like I did in the lesson and the homework. Okay, so gotta remember it's so, right? So for a to the 3 plus b to the 3, we have that plus sign there, so it's going to be the same, opposite, always positive. And for a to the 3 minus b to the 3, it'll be same, opposite, and always positive. Okay, so for x to the 3 minus 125, I'm going to start off by identifying what am I cubing. This is x cubed plus 5 cubed. So, I'm going to use kind of that formula, and a is going to be x and b is going to be 5. So I've got x plus 5 multiplied by x squared minus 5 times x plus 5 squared. Then for a to the 3 plus 64, okay, that's going to be a cubed plus 4 cubed. Okay, so I'll be using the sum of cubes again. Okay, yeah. And so that's a plus 4 multiplied by a squared plus 4a plus 4 squared. I'll bring the pattern down as I keep working. So x to the third minus 64, that's going to be x to the 3 minus 4 to the 3. So I'll be using this one right here, x minus 4 multiplied by x squared plus 4x plus 4 squared. Yeah. No, I did that wrong last time. Okay, yeah, it didn't feel right. But I still don't think it's worth, starting over on the video for. Remember, it's the same, opposite, always positive. Okay, and you should check your work against your general formula. Always, obviously. Okay, so yeah, same, opposite, always positive. Now for u to the 3 plus 8 is going to be a sum of 2 cubes. It's going to be u cubed plus 2 cubed. And I'll have u plus 2, okay, same, u squared, opposite, minus 2u, plus, always positive, 2 squared is 4. To the 3 minus 27, that's x cubed minus 3 cubed. So I'm going to have x and 3, x, 3x, and 9. That's one way you can set up the skeleton like that, and then just put in the signs to make sure you're doing it right. Right, the first number, or the first thing, the second thing, and then the first thing, the product of the first and the second thing, first thing squared, I'm just making errors all over the place, first thing squared, product of the first and second thing squared. Okay, so I'll have same, opposite, always positive. Okay, that looks right. Okay, 125 minus x cubed, that might be something we could look at as 5 to the 3 minus x to the 3. Okay, so just like before, it's just going to be first thing, second thing, first thing squared, product of the first thing and the second thing squared. And then it's same, opposite, always positive. Okay, and it doesn't matter if the x is first or the x is second, it's not really relevant as long as we just stick to the pattern and go with our skeleton and fill in the right signs. Alright, the next two, 1 minus a to the 3, so that's 1 to the 3 minus a to the 3. So I'm going to have same, 1 minus a, 1 squared is 1, 1a and a squared, same, opposite, always positive. A to the 3 plus 125, that's a to the third plus 5 to the third. And so I'll have the same, opposite, and always positive. And did I not already do x to the 3 plus 27? It feels like I did, but I don't know, maybe I didn't. So I'll have, that's x to the 3, I guess we did x to the 3 minus 27 plus 3 to the third. But it's good, I don't need them to give you a whole bunch of crazy numbers that we don't know. I'm glad they're kind of sticking to 125 and below, at least on this page. So we're going to say that that's x and 3, same sign, x squared, 3x, and 3 squared, opposite sign, always positive. And for x to the 3 plus 1, that's going to be x squared, 1x, and 1 squared, same, opposite, always positive. This one, okay, now we're getting some a little bit more interesting ones. Okay, that's 2x taken to the third power plus 3 taken to the third power. And so I'm going to have 2x and 3, and that'll be the same sign. Then I'll have to square 2x, and if I take 2x and I square it, it's like multiplying 2x times 2x. So I have 2 copies of 2 and 2 copies of x. That's 4x squared. If I multiply 2x times 3, that'll be 6x. And 3 times 3 is 9. Okay, that's great. I think I told you in the lesson, but I will reiterate once again that this thing here that we get when we factor a sum or difference of cubes, it will never be factorable. So you're never going to have to take this thing on the right and factor it even farther. Okay, number 12, negative 27u to the 3 plus 125. Okay, now you could go over here and say that this is, I think, negative 3u taken to the third power and do a sum of cubes, but I don't really like that. I'm going to just rewrite this as 125 minus 27u to the 3, and I'll do a difference of 2 cubes. Okay, so here this is 5 to the third, and this is going to be 3u to the third. And so I'll have 5 and 3u with the same sign, then 5 squared. 5 times 3u is 15u, and 3u squared would be 9u squared. Okay, so I have the same sign here, opposite sign there, this is always positive, and there I've got it factored. Okay, you would have gotten something equivalent if you factored it with the sum of 2 cubes, one of the cubes being negative 3u. I just, it would have been more unpleasant. I can see how it would work. Negatives would cancel, things would be rearranged, it would be equivalent, but I think that was the way to go for, at least for the people in my class. Alright, how many more of these do we have? Oh boy, lots. Okay, well, that's good. We need our practice. This is new to us. Okay, let me shrink this page down a little bit. Okay, yeah, this will be good. So, alright, negative a to the 3 minus 8. I'm factoring out the negative first, because it looks like a greatest common factor, right? And then this will be a sum of 2 cubes. So I'm going to factor out the negative, and then I'll have, this is a to the 3 plus 2 to the 3, so I'll have the same sign, a squared, 2a, and 2 squared, same, opposite, always positive. Yeah, much easier that way. Okay, over here, oh, okay, I see what we're supposed to do here. We're going to factor out a 2 and an x first. And then we'll be left with 125x to the 3 plus 64. Okay, 125x to the 3 is going to be the cube of 5x, and 64 is the cube of 4. So I've got 5x and 4. I'm going to scroll over here, I guess. And same sign. Square 5x, get 25x squared, multiply 5x and 4 and get 100x. Opposite sign, always positive, square 4, that's 16. And yeah, that looks good to me. Okay. Now, well, I don't know anything about 1029. Let me think. Okay, the only like really big arithmetic trick I know is that if you add the digits of a number up and they add to a multiple of 3, it's divisible by 3, and same with 9. So 9 plus 2 is 11, plus 1 is 12. Okay, so I know that this one's divisible by 3. So if I divided it by 3, I'd get 300 and something. But I'm just going to go ahead and say that we're in a no calculator class, so I'm saying that this one's not reasonable. Okay, this one, I don't know if there's something I'm supposed to be realizing about that. I see that you're supposed to be able to factor out an A. Maybe 648 and 1029 have common factor in there somewhere. Maybe they both have that 3, but I don't care. That's not realistic. That's not representative of a problem I would give you in my class. So this is 2a taken to the third power, getting 8a cubed, and 5 to the third power, and a sum of 2 cubes. So I've got 2a and 5. Those are my cubes. And I'm going to have the same sign here. The second factor will have, when I square 2a, I get 4a squared. 2a times 5 is 10a, and 5 squared is 25. Okay, same, opposite, always positive. And that's as far as I can go. All right. 64x to the 3 plus 1. Okay, so this one is going to be, I took 4x and cubed it plus 1 and cubed that. So sum of 2 cubes, I'll have 4x and 1. If I square 4x, I'll get 16x squared. 4x times 1 is 4x, and 1 squared is 1. Okay, I'll have the same sign here, opposite sign there, always positive there. And then 8x to the 4 plus x, that's got a greatest common factor. I'm going to need to factor out that x first. And then I've got 8x to the 3 plus 1. 8x to the 3 is the cube of 2x. So I'll have this original x, and then I'll have 2x and 1. And I'll need to square 2x, multiply 2x and 1, and then square 1. Okay, it's a sum of 2 cubes, so it'll be the same sign, opposite sign, and always positive. Alright, just a few more of these. Okay, and then now we're kind of, into the multiple variables situation. So like I did on the other worksheet, I think it was group and factor, I'm going to kind of stop here. I will go in and I'll do 2 of these, just like in case you need the extra fun of having 2 variable situations. I think I'll do number 19 and then number 23 also, just to see what's kind of going on with those, because that number 23 looks like an extra layer. So I think it's 343 is 7 to the third power, because 49 times 7 is just a little bit less than 50 times 7. Yeah, that's the situation here. So I'm going to say, all right, this is 7m taken to the third power, and this is 4n taken to the third power. So when I do sum of 2 cubes, it'll be 7m and 4n. Okay, if I square 7m, I'll get 49m squared. If I multiply 7m and 4n, I'll get 28, and an mn. And if I square 4n, I'll get 16n squared. And because this is a sum of 2 cubes, this will be the same sign, opposite sign, and this sign will always be positive. And so, see, it wasn't that different, but we've got multiple variables moving around, and again, I'm not going to ask you to do that in my class, because this is an Algebra 2 class. Okay, and we're not really all that concerned with multiple variables. Okay, only as like an extra challenge occasionally, like right now. So this one, 1029 again. Okay, I gotta look this up. Okay, yeah, I was not going to be seeing that. The deal that I guess we would need to know about 1029 is that it's equal to 343 times 3, right? Because we get 900 from 300 times 3, another 120 from 40 times 3, and then 3 times 3 is that extra 9. Okay. I did not know that. I had to look it up. And so, yeah, and 24 also divisible by 3. I mean, 343 being a cube number was kind of at the edge of my arithmetic skills, so 1029 being a number I was supposed to know, that I just don't think that was realistic. But now that I know this, I think I'm good to go, because I can factor a 3 out of 24 as well. And then I will be able to factor out one copy of y. So I've got a 3 and a y, and then I'm left with 343x cubed plus 8y cubed. Okay, nice. Yeah, this one had a little bit of an extra layer. That greatest common factor. 343x to the 3. I'm going to put my little note in here that's 7x cubed and 2y cubed. Okay, so I'll still have the 3y, and then I'll go to do sum of 2 cubes, so it'll be 7x and 2y. I'll square 7x, multiply 7x and 2y, and square 2y. And because it's a sum, this will be the same sign, opposite sign, always positive. And I think that's going to be enough sum and difference of 2 cubes practice for us for today. You know, if you've done all these, hopefully you're remembering the pattern now. If you're not, then, you know, I'm going to tell you to just go back and do them again. You know, keep writing that pattern down. Where was it? Up here. This is what you need to write down. And one thing that can help is that, you know, every time you do a sum and difference of 2 cubes problem, you can write down the skeleton for both of them, right? And that will help you remember. All right, so that's all I got. Thanks for watching.